Hi everyone, let's read a new paper about RAG today. There is a recent paper that introduces a new solution for accurate question answering, especially if you have long documents. This paper is called GARLIC, LLM-Guided Dynamic Progress Control with Hierarchical Weighted Graph. I think it is a new and interesting way to build a RAG solution. So, what makes GARLIC so special? Let's look at this diagram. It uses a hierarchical graph representation of documents to improve information retrieval instead of traditional chunking or knowledge graph. So let's dive deep into summary graph construction. Rather than using traditional chunking methods, Garlic uses LLM summarization to transform documents into a hierarchical graph structure. Each node in this graph focuses on a single fact or multiple smaller facts, referred by the authors as information points. The deeper we go into the tree, the more detailed facts contained in each node will be. Let's see how the authors plan to do this transformation. Let's see the prompt. The process starts from splitting the text into chunks of 300 words, which serve as the first level of nodes. Then we take these nodes, summarize them, and get higher level nodes. The authors suggest using LLM annotation weights to get weights of each edge between nodes. So, here are the chunks from the raw document, and here is the layers of summarization. And here are the edges that connects chunks and summarization. Some summarization point or information points as the authors name them. This process forms a many-to-many graph in which each node can have multiple lower level child nodes and higher level parent nodes. When we have built this hierarchical graph, we could make a dynamic search. Let's look how it is working. Here is a diagram. So the system looks at some top level points in the document and then asks itself, is this enough information to answer the question? We could also check the prompt for this question. In fact, there are two prompts. First prompt, if the information is enough. And the second prompt, if we get yes. And the separate prompt, if we see yes, we will try to answer the question. So how it works? Let's return to the diagram. Here it is. The system checks if the information it has is enough to answer the question. If not, it grabs more information and keep asking the same question. It looks at how much attention each point of information is given to the question. The more a node is focused on the question, the higher is its importance. The system picks the next node based on its attention score and how it is connected to other points. Once the system thinks it has enough information and tries to answer the question. The system can decide to stop gathering more information when it believes the answer is ready. It does this carefully to avoid getting too much or too little information, which makes it more efficient than older methods. Okay, let's see the results on metrics. Here we can see results on different datasets, well-known datasets. Okay, here are the metrics. F1, Roach L, Leo 4, TFLOPS. TFLOPS stands for Terra Floating Point Operation during search. Here we can see good results of these methods on these well-known datasets. Now let's check some obvious limitations and challenges of this approach. First, currently no public implementation exists. You have to read this paper and understand how this approach is working. But the authors they stated all main ideas, and you could implement it from scratch. Second, this approach of summarization is resource intensive in terms of graph organization and processing. The authors made an efficiency analysis. They calculated how much TF-flops they used to generate the graph and how much TF-flops is used for each search. So in the long run, if you have a static set of documents that aren't updated regularly, there won't be much difference in operational costs. The next risk is summarization, because sometimes there is a risk of hallucination during the graph creation phase. So there is a risk that some of the facts would be taken not from the document, but from the LLM itself. Okay. And the final thing that I want to mention is that this research was made using Llama 3 and 3.1. And if you try to implement this on some proprietary LLM, you might not have an option to get attention weights. All in all, what I find most exciting about this paper is how it rethinks the entire approach to document processing. Also, the use of attention weights for navigation is very promising, and I think that it separately needs to be studied. What do you think about this approach? Could this be the future of document search, especially for long documents? Let me know in the comments below. And if you are interested in more AI papers breakdowns like this, don't forget to subscribe and hit the notification bell. Thank you for watching, and I'll see you in the next video.